This conference will now be recorded.
Okay. All right. We are in day 8 session. In the yesterday session, we already had a discussion on top of packages and access modifiers. So we have seen the uses and what do you mean by package and what do you mean by access modifiers and how we are using, how exactly we are working with respect to practical. All these things we have seen in the yesterday session. All right. So now in my today's session, I will start with what OOPS principles. I will start with what are OOPS principles. I have told you already, Java is a object-oriented programming language. Java is a object-oriented programming language because it is following OOPS principles. What are the OOPS principles we have? We have 4 OOPS principles are there. One is inheritance, polymorphism, third one is abstraction, and encapsulation. If any programming language is following these principles, all such kind of programming languages are object-oriented programming languages. So just I will try to give you the definition, each and everything, so that I will again take, okay, I will try to explain. I will try to explain each and everything. I hope my voice is audible to everyone. Somebody messaged me. Right. Is my voice is audible? But there is truck. Okay. Okay. No sound. Please cross check. Please cross check your mic once. Okay. So these are the 4 principles we have. First, I will try to give you the definitions. First, I will try to give you the basic informations, and again I will take one by one with the clear examples. We'll see. Okay. So what do you mean by inheritance? Inheritance is the process of acquiring the properties from parent class to child class, or taking the acquiring or taking, both are same. Inheritance is the process of getting the properties from parent class to child class. Okay, inheritance is also known as easier relation. In Java, we have different relations are there, like is a relation, has a relation, uses a relation, something like that. Inheritance comes under is a relation. With respect to relations wise, we are representing this inheritance as something like is a relation. And one more point is here you need to understand. Yes, I understood the definition. So far, whatever the programs we developed, all those programs contains only one class, whether you are observing or not. Here it is one class. Okay, here this test 1 is one class, test 2 is one class, test 3 is one class. All even default package also, everything is an independent class, only single class. But whether you are observing this definition or not, parent class is there, and then as well as what child class is there. So to achieve the concept of inheritance, we require minimum 2 classes with a parent-child relation. We require 2 classes with a parent-child relation. That is what we need to remember. Right. So what is the advantage if you are maintaining the relation? If you are maintaining the relation in between the classes, what kind of advantage you are getting? Basically, what is the advantage of inheritance? Again, the same concept, reusability. What is the concept? Tell me. Reusability. Concept is what? We are achieving the reusability. Because of this redundancy, code redundancy. One second. So code redundancy. Redundancy means duplication of the code will be decreased. Because of that, because of all these factors, performance of the application will be improved. Performance of the application will be improved. So how exactly we are achieving the concept of reusability? How code redundancy will be decreased? Because of inside the parent class, we do have some logic. The same logic, if I wanted to access from my child class, happily, instead of redefining the same code which you already defined inside the parent class, I can reuse whatever you define inside the parent class. If I wanted to access the same logic, or if I wanted to reuse from my child class, I can reuse. Along with the parent class properties, if you want to define your own properties inside your class, inside the child class, yes, you can also define those properties also. Like how exactly our real-time parent-child relation is there, the same thing is also working here. Meaning that how exactly our parent class, our parents assets we are getting, and along with the parent properties, if you want to maintain your own properties also, yes, it is possible. In the same manner, inside the parent class we have some properties. Along with those properties, if you want to define the child class specific properties also, it is possible. Meaning that parent class contains only parent class properties, whereas child class contains child class properties and as well as parent class properties, because child class is derived from the parent class. Child class is derived from the parent class. So that is why minimum two classes are required with this parent child relation. Yes, programmatically, I will tell you how exactly we are achieving, but this is the basic definition of what inheritance itself. And we'll go to like what polymorphism. We'll go to like what a polymorphism. So what do you mean by polymorphism? Defining one thing, or else defining one action, defining one thing or else one action into many forms. For example, I'm a person. Right now, I'm acting as a mentor object. Okay, I am behaving like a mentor right now for all the students who joined. The same person, if I go to my home, I'm acting as a son object. I'm acting as what? Son object. If I'm going to like what some bank to perform some bank operations, there I'm going to like what acting as a customer object. Because if you're observing, person and then son. Who is person? Son is a person. Come on, please. Son is a person. Customer is a person. So what kind of relation is there? Here, consider this person as a class. Person has some properties. And so this customer is also has some properties. Class customer. And this class son. Okay. For example, if you go to somewhere, so like this, different objects are there. Different classes are there. What kind of relation is there in between person and then son? Is a relation, because of person is a son. Person is a customer. Whatever the details of the person, those details are available inside the son also. And along with that, some more objects, some more information is also there. So whatever the details are there inside the person, those details are also available inside the customer. Along with those details, customer is maintaining some other information. So same object is behaving like based on the context, it is behaving like different. So that is the concept of what? Polymorphism. That is the concept of what? Polymorphism. Yes, we do have different types of polymorphisms are there in Java. One is compile time polymorphism. Another one is what? Runtime polymorphism. How we are achieving these things practically, I will show you when I'm talking about specifically about this polymorphism. First, try to understand the purpose and the definitions of these OOPS principles. Just if you get the overall, the basic information, basic idea, then I will take specifically one by one, and I will try to like what elaborate with respect to programs. Yes, you may ask one question: how like polymorphism? What is the basic purpose of polymorphism? Yes, basic purpose, like how exactly? One second. One second. So how exactly we are achieving the concept of reusability, code redundancy will be decreased by using this inheritance principle. In the same manner, we do have some kind of advantages are also there. What kind of advantages? I can say something like, programmer's code can be reused, of course, via polymorphism. Okay. So, and moreover, so saves a lot of time. So single variable can be used to store multiple data types. So, and we can easily debugging the code also. Okay, we can easily debugging the code also. So ultimately, what are the advantages we are getting all on top of this particular polymorphism principle? So I can write something like this. It allows programmers to reuse. It allows programmers to reuse, evaluate, and execute the program. So you may use the odd variable name to stock variables of different types of data, such as int, something like float, something like this. For example, if you are defining one variable, okay, of one type, that particular variable you can define in some other data type based on the requirement itself. So, and moreover, it is trying to like what reducing the something. It is trying to like what reducing the coupling between different functionalities. Okay, reduces coupling between different functionalities. Yes, you may not understanding this. We do have a different loose coupling, tight coupling is there. Those were the concepts actually we are going to talk in the upcoming advanced frameworks like Spring, something like that. So this runtime polymorphism helping us to reducing that coupling between two different components like classes also. Okay, so majorly this polymorphism also, especially we are achieving this polymorphism by using two concepts in Java. One is a method overloading, another one is what? Method overriding. So using method overloading, we are able to achieve the concept of, or else it is used to like what? Improve the readability of the code. The readability of the code will be improved. So by using method overriding, okay, we also can able to like what? Achieve the, if you don't want the, if you don't want to like what? Achieve the existing functionality, if I want to like what? Based on the client requirement, if I wanted to like what? Give you the updated updated functionality or updated behavior, then obviously we should go for what method overriding. Example, for example, rate of interest method is there. Okay, rate of interest method is there. Assume this rate of interest method is giving you the rate of interest. When I started my bank services, that time it is returning. That time it is returning what 4.5. 4.5 is the rate of interest. But right now, as my services, as my day-to-day activities, my rate of interest supposed to be changed from 4.5 to something like 5.5. So that time I'm not going to to change the existing logic. I'm just taking this method and I'm just overriding, I'm just changing this logic. That is the concept of what method overriding. I don't want to touch the existing logic. I wanted to provide the updated logic with the same method. That is the concept of what method overriding. So using these two concepts, we are able to achieve this polymorphism. So ultimately by using this polymorphism, we are able to, it allows programmers to reuse and evaluating and executing the program. Reusability only we are able to achieve. Okay, and coming to how practically we can achieve all these things, I will specifically talk about this, and then I will I will try to deep dive into those concepts. And one more thing is abstraction. So abstraction, uh, definition wise, it is the process of retrieving or accessing required details. Whatever the details we are requiring, okay, we are accessing only those details by ignoring irrelevant details. Whatever the details we don't require, we are just ignoring. For example, if you are driving the car, what is your main target? Whether the car functionality is working up to the mark or not. I mean to say, whether whenever you are pressing on the accelerator, whether it is increasing the speed or not. When you press on brake, whether it stops the car or not. Those things only you have to focus. Instead of focusing on those things, are we focusing on how they have designed internally? We don't require actually, isn't it right? So for example, right now I am taking the session. So what is your focus right now? Whether you are understanding or not, you don't know the background work, what I did or what I am doing, you are not least bother about that. Just like that, you are attending the session and whether you are getting or not, that's the only the point. So this is also kind of abstraction. So abstraction is saying what? We are just focusing on what we want. We don't know how they have implemented. How that got implemented, we are least bothering about that. Whatever we are requiring, the services we are getting or not. Isn't it right? That is the concept of what abstraction, and this concept we are achieving by using one concept like interface. That I'll tell you later. Of course, using abstract class also we can achieve, but partial abstraction is possible by using abstract class. So this is the basic information regarding about what abstraction. It is the process of getting the required details just by ignoring the irrelevant details to you. Right. Coming to what encapsulation. What do you mean by encapsulation? So again, using abstraction also, we are able to what is the main target here? What is the purpose? What is the advantage? You are getting the security, modularity, isn't it? Modularity, reusability, all these things again, also the benefits of what? Using abstraction. Encapsulation. This is the last object-oriented programming principle. Yes, little theory is there, but we need to understand first theory. Later, we'll try to understand programmatically. Encapsulation is something class only. Class is the best example. Class is the best example for encapsulation. How can you say class is the best example? First of all, what do you mean by encapsulation? It is the process of wrapping up of or else clubbing. It is the process of combining variables and methods into a single unit. And this process is what we call encapsulation. So where we are clubbing where we are clubbing. It is a class is the best example for encapsulation itself. Class is the best example for encapsulation. Inside the class also we are clubbing variables and as well as what methods. So yes, so because of this encapsulation, what is the advantage we are getting? Data hiding. We are able to like what hide the data. We are able to like what protect the data. Okay, so to achieve this encapsulation, you have some rules are there inside the class. While you are wrapping these variables and methods, we have some rules are there. Then if you follow those rules, we can make our normal class as an encapsulated class, so that we can achieve the concept of what? We can achieve the concept of what? Data hiding. We can achieve the concept of what? Data hiding itself. How we can protect the data? Usually by declaring the variables as private. Yesterday only we have seen. So how still those we have some some kind of scenarios are there. Those scenarios also we'll try to like what understand. So one by one, whatever the OOPS principles I told you, try to understand. Inheritance, it is a process of taking the properties from parent class to child class. Using this, we are achieving the concept of reusability, and we are able to reduce the redundancy of the code. And coming to like what polymorphism, it is a process of defining one form into many forms. Because of this also, we are able to like what achieve the, we are able to like what reuse the code with respect to like what different contexts. And when it comes to like what abstraction, it is the process of getting the required details by ignoring the unnecessary details. We are only focusing on whether the service is happening or not, whether the functionality is happening or not. Usually we are achieving this abstraction by using the concept of interfaces and of course abstract classes also. When it comes to like what, here also using this abstraction, we are getting the security majorly. That is the benefit. So encapsulation, it is using this, we are able to achieve the concept of data hiding. So ultimately, whether you are observing or not, so segregation, modularity, enhancements, debugging. Come on, please. Enhancements. Enhancements means what? Based on the client requirement, we are going to like what update the code as per the client requirement. That is what we call enhancement. Modularity. We are separating the codes. When you are separating the codes based on the different functionalities, when we are getting any bug, when we are getting any issue, we can easily find out where exactly we are getting that issue, and easily within the very less time we can able to like what fix it up. We can fix that particular bug. That is the concept of, that is why while we are developing the code, instead of defining that entire logic in one class, we are going to like what segregate, we are going to separate. That is the concept of modularity. So enhancements, modularity, when you do the modularity, obviously we can easily debug the code also, where exactly that error was there, we can easily debug. And security, reusability, all these are the final benefits of what all object oriented programming principles. What are the benefits we are getting of any, take any object oriented programming principle, it will be applicable to any other object oriented programming language. What kind of advantages are there? If anybody is asking what are the benefits you are getting, benefits of, come on, benefits of OOPS principles. These benefits are not only applicable, are not only exclusively for Java. These benefits are for any programming, any object oriented programming language. What are the benefits? Enhancements. Okay, enhancements, reusability, security. Okay, something like enhancements, reusability, security, modularity. Okay, easy maintenance. Okay, debugging will become very easy. Okay, etc. So all these are the main benefits of what all the OOPS principles. I hope you understand the basic information or basic idea of what on top of these OOPS principles. right? So you may ask one question, what do you mean by debugging? Yes, we do have a separate session. How can we debug? Okay, all these are, you know, the theoretical points. Practically daily in our work, we are going to see this. Enhancements means what? Based on the requirement, we are going to update the existing logic, or we are going to add some extra code. Reusability, as you already aware. Security, logic is not visible. Only we are accessing the service. So in that way, we are able to provide the security. Modularity, separation, easy maintenance. Easy maintenance means what? Instead of when you are trying to like what resolve, because when you are clubbing all the code in once, you can't. When you are segregating modularity, if you are maintaining the modularity, we can easily maintain the code when something goes wrong. And debugging, where exactly that error is there, how this is working, from which flow, from which class to other, which class it is going. So in this way we can debug the code, and we can understand where exactly it is going wrong. So accordingly we can fix the issue as soon as possible. So debugging will become easy when you are following this modularity concept. You know, all these are the benefits which we are getting when we are applying the OOPS principles while you are developing the application. That is why the object oriented programming languages are very much popular compared to procedure oriented. Okay, so Java is one of the object oriented programming language, since it follows these principles. So how practically in Java we are able to achieve these principles? Using two concepts. One is a class, another one is what? Object. One is class, another one is what? Object itself. You know already how we can define the class, how we can create the object, what happened when object will be created, what happened when you define the class, from where exactly the execution of the Java program starts. All these things we have already had a discussion. So now I will take first OOPS principle, that is what? Inheritance. I will take the first OOPS principle, that is what? Inheritance. As I told you, it is the process of taking the properties from one class or parent class to child class. Parent class to child class. So here I wanted to ask one question. What do you mean by parent class? It is a class which is giving the properties or taking the properties, which is giving the properties. What do you mean by properties? Whatever we can define inside the class, all those are what? Properties only. Whether it might be variable, whether it might be block, whether it might be constructor, whether it might be method, whether it anything, whatever you can define inside the class, all those are going to be considering in general word as a property. All right, coming to like what? Child class. What do you mean by child class? It is also a class. It is also a class, but which is taking the properties. So child class is always taking the properties. Child class is always taking the properties, whereas parent class is always giving the properties. So I wanted to tell you one point here. How practically we can achieve. For example, let me open my here. So we have a default package P1, P2 package. Now since we are working on the inheritance, I will try to like what? Create the one package, com.jse.inheritance. Okay, this is my package name. In this way, we are going to like what? Define the packages while you are working on the real world projects. So since right click on this, new, take the class. Here test1 is the, or else parent is the class. Parent is the class. This is my class name. So inside the parent class, I have one method is there, assume public void sum, and this is the logic. Okay, this is the logic which gives you sum plus of x plus y. Save it. This is the logic which I am defining inside my parent class. So now whatever the logic you defined, so this is one property which you are defining inside the parent class. Now I wanted to define the child class. How can you define the child class? Let me under right click on this package, new, take the class. What is the class name you want to give? Child only. So whether you are observing or not, for this is the child you are going to define now. For this child class, who is acting as a super class which you want to give? You want to make which class as the parent class for this child class? The parent class, right? That is the reason. Click on the browse. Okay, here type parent so that you can select this. Okay, now click on the finish. Then automatically this will be appeared. Public class child extends parent. Sir, if you don't want to do like that, you can manually also delete. You can manually also do something like this. New, take the class, child is the class, but right now this is the child class. But actually it is not a child class. The name of the class is only child. But to become or to make this class as a child class, what we have to do, you have to use extends keyword. Extends parent. Whenever you are using extends parent, automatically whatever the properties you are defining inside the parent class, those will be inherited into this child class. So right now inside my parent class, how many methods are there? Sir, one method. That is what method? Some method. So inside the child class, how many methods are available now? Since we are already using extends parent, automatically that some method also will be inherited into this child class. Of course, it is not visible. Physically, it is not visible, but logically, it is available. Logically, it is existed. Okay, since we are using this extends parent. Okay, sir, how can we prove that? Okay, my parent class is ready, my child class is ready. Now, what I want to do is, I want to create the execution logic class. What do you mean by execution logic class? Wherever you are defining the main method, that is the execution logic class. Because of execution of the Java starts from the main method only, na? Right. So now which class object you have to create? Child class or parent class? Any class object you can create, that's not a problem. But right now, you tell me now, inside the child class, also we have one more method is there. What is this method? System.out.println subtraction plus of x minus y. Now tell me, inside the child class, how many methods are there? Only one method or two methods? I am observing your chat box. Just to give the response with respect to number. So in the child class, how many methods we have? Give me your response in the chat box. One or two? Come on. Okay. So the answer is what? Two itself. Because one is coming from parent, another one is available inside the child. So ultimately, my child class contains two methods. One is a sum method, which is coming from my parent, and another one I defined. So ultimately, my child class contains two methods itself. My child class contains two methods. One is physically available, another one is logically existed. So whenever you are applying the inheritance concept, it is highly recommended to create the object for child class or parent class. For example, if you create the object for parent class, parent obj equals to new parent, what will happen with this object? Only you are able to access, only we are able to access some method only. Why? Because whenever you create the object for the parent class, memory locations will be allocated for only parent class properties. That is the reason with this object we are able to access only parent class properties. You can't access child class properties. So that will become the problem, right? That is the reason we have to always create the object for child class. Okay, when you are creating the object for the child class, memory locations, memory will be created for both parent class and as well as what? Child class. Of course, it is distributing the same memory, but allocating the, okay, both parent and as well as what? A child. It is utilizing the same memory copy, but ultimately for all the properties, the memory will be created for both child and as well as what? A parent itself. So that is the reason using this object, we are able to access the sum method, which you defined inside the parent class, and as well as what? Sub of 4,3. Am I getting any error? No. But when you are creating the object for the parent, immediately we are getting the error for the sub method. Why? Because the method sub is undefined for the type parent, because of you did not define the sub method inside the parent class. But obj is of parent type. That is the reason we are getting the error. So that is the reason my conclusion is what? When you are applying the inheritance concept, it is highly recommended to create the object for child class, so that it will be memory locations will be created for both parent and as well as what child class. So using the child class object, we are able to access the parent class properties and as well as what child class properties. But when you create the object for the parent class, with that object only we are able to access parent class properties only. When you are trying to access the child class properties using parent class reference variable, we are getting the compile time error saying that property not found. Okay, let me try to like what run this application now. We are able to like what getting the sum and as well as what subtraction. Let me copy this. Let me copy this. And this is the basic example of inheritance. So ultimately, node point is what? How can we achieve the inheritance using extends keyword? We are able to achieve the inheritance concept. We are able to achieve the concept of inheritance. So where should we use extends keyword? In the context of child class or parent class? We should always use extends keyword. Come on, we should always use extends keyword in the context of a child class only. In the context of what? Child class only. In the context of what? Child class only. So you just observe here. Okay, only I am passing the test one, na? Execution logic class. Okay, so I have to like what pass parent.java and as well as what child.java also I supposed to take the backup. Test1.java. This is an execution logic class. I can define all these classes in one class also. That's not a problem. But for clear understanding, I'm just defining into different classes so that you can understand which one is the parent class, which one is as the execution logic class, which one is the child class. You can clearly understand. Let me open the child. Control C. Come back to here. Control V. Yes. Okay. So that is all about what basic inheritance, the demo program itself. Now I wanted to tell you one more point here. Please tell me if you are observing my child, who is the immediate parent class for this child? I'm asking who is the immediate parent class for this child? Okay, obviously answer is what? Parent. So control goes to parent. So now again I'm asking what is the, do we have any superclass for this parent? Do we have any superclass for this parent? Do we have any superclass for this parent? I am not seeing extends any other class. So that is the reason nothing you feel. But even though you are just defining one class, for example, let me try to like what define one class. Here make it as what test2. Here define the main method or else public void m1. Okay, system.out.println of parent class or else test2. Okay, m1 method. Simply I'm just writing one message. Okay, after that you define the main method. Okay, create the object for the test2 obj equals to new test2 and you are calling obj.m1. This is not a I mean this is a simple program, right? Inside the test2 I am defining m1 method and after that I am defining the main method, creating the object and accessing. This is simple. So m1 method you are calling on top of this object where obj is of test2. So then control goes to the test2 class and looks for the m1 method and this logic will be executed and we are seeing that output in the console when you run this application. Okay, now if I call obj dot hash code, obj dot hash code system.out.println of, if I am calling control X, okay, keep it inside the control V, obj dot hash code. Okay, obj is a reference variable of test2, meaning that it is an object of test2. But inside the test2, do we have any hash code method? Please confirm me. Do we have? Did you define? Sir, only I defined m1 method, sir. But I am not seeing hash code method. But how can you call this hash code method? If the method, so if it right now, again, please tell me, you created the object for the child class. But with this child class object, you are calling the sum method. But inside the child class, is there is any sum method? No, no sum method. But still, it will check for that sum method in which class? It's parent class. So then control goes to this parent class and it will just check for the sum method is there or not there. It is there. That is the reason it is not giving you any issue. in the same manner, I am calling the hash code method. I am calling the hash code method on top of this object of test2 type. So then control goes to the test2 class. Any method is there with respect to hash code? Yes or no? I am saying your chat box, please. Yes or no? Hash code method right now it is available inside the test2 class or not? If it is not available, then it will Java compiler will check for its parent class. Then who is the parent class for this test2? Who is the parent class for this test2? Right. So here Java compiler automatically adds a one concept, that is what extends object. Meaning that what? For every Java class, sir, you no need to write this explicitly. This will be automatically added by the Java compiler for any Java class. So ultimately, what is the note point I wanted to tell you here? For every Java class, okay, whether it is predefined or user defined, any Java class, take any Java class, sir. We don't have any restriction. For every Java class, whether it is predefined or user defined, we have one super class, that is java.lang.object o should be capital. Sir, if you are not believing, object class API in Java, okay, open docs.oracle.com, okay, control, see here, java.lang.object. Can you please read out this? Class object is the root of the class hierarchy. Every class has object as a super class. Okay, it got introduced in JDK 1.0. So meaning that for every class in Java, this object class is acting as a parent class. What kind of methods we have? We have a clone method, we have a equals method, we have a finalize method, we have a get class method, we have a hash code method. That is why we are able to access this. Since the hash code method is available inside the object class, I am not getting the error here. Okay, so not only hash code method, all the other methods like clone method, equals method, finalize method, get class method, toString method, wait method, notify method, notify all method, all these are the different methods which are available inside the object class. Okay, for example, if I run this application, control goes to the object class hash code method and that logic will be executed. So control shift T. Okay, if you want to see the object class logic, click on this. See, this is the class object they have defined. This was defined by whom? Sun Microsystem. Okay, this code, see here, how many lines of code is there for the object class? 569 lines of code is there. Okay, inside this, we are looking for which method? Tell me. Hash code, right? Just control F, hash code method. Okay, this is the hash code method. What kind of logic is there? Okay, 1 second. Hash code method, control click open implementation. Try to habituate like this to understand, or we are trying to like what understanding the how they have implemented this predefined methods and then predefined classes, something like this. Okay, I'm just clicking on this. It's just taking some time. Just wait. I wanted to show you what kind of logic they have implemented. After observing the logic, we can at least expect the output. Okay, just wait. So ultimately, my final conclusion point is what? For every Java, what happened? In Java, for every class, there is a super class, that is what? Object class. Inside the object class, we have already almost 11 methods are there. These methods you can able to access from any class because of object class is acting as a super class. If a method is not available in our class, then Java compiler will check for those methods inside this parent class. Okay, so the same thing is happening here itself. Okay, but it is, we just read only. 1 second. Is not responding. 1 second. Yeah, here you see. Yeah, I have got it. When I control click on this hash code method, control, when you keep the cursor here, you just click on the control and you will get this open declaration, open implementation. When you click on the open implementation, where in which class they have implemented, control, it will be redirected to here itself. So see here, public int hash code method. Here it is returning the hash code. When you create the object, for every object there is a hash code, unique hash code is there. It is returning get class hash code get id dot hash code. Okay, get class dot hash code. So something like this. It is returning you the hash code value. For every object there is an hash code, and that we are getting. And this is the logic. And this is the logic. You see, you just observe here. Let me come to here. When I try to run this, okay, see here. This is the, yes, you may ask one question, sir, how we are getting this hash code value? Internally, it follows some hashing algorithms to generate this hashing number. So accordingly, this will be coming for I hope you understand. For example, if I'm creating one more object, test2 obj1 equal to new test2. For every object, there is a different or unique hash code. System.out.println of obj1 dot hash code. Save it. When I try to run this, am I getting the different hash code value or not? For example, if you are creating 100 objects, for each and every object, there is a unique hash code value will be generated. With the hash code only, we are able to like what uniquely identify the objects. So, but ultimately, that is not my point. Here, what I wanted to explain here, for every Java class, there is a super class, that is java.lang.object. So whatever the methods are there inside the object class, all those methods we are able to access from any Java class. This is the practical proof. Okay, sir, you may ask one question. Sir, can you please show me some other methods? Yes, based on the requirement or concept, I will get a chance to show all those methods also. But for now, I will try to show you some other methods. obj.getClass. You see, getClass method. I am obj. If you keep the cursor, getClass method is giving you the class as the return type. When you try to run this, see here, class com.jsc.inheritance.test2 is the class name. It is giving you the fully qualified name. Okay, like this, system.out.println of obj.toString method. I'm calling the toString method. I'm calling the toString method. So inside the toString method, see here, if you want control F, toString method. Okay, see here, what is the logic? It is there. It is returning get class, get name. It is returning a string representation of the object at the rate of integer dot 2 string of hash code. Whatever the hash code it is generated na, that we are converting into hexadecimal value, and that will be appended to at the rate and followed by class name. So ultimately, if I run this application, see, you just observe. When I try to run this, here you see last one, class name at the rate of what? Hash code only. But this hash code is not the integer value. This hash code is the hexadecimal value. So in this way, for every object, these methods are helping. That is the reason these methods they are defining inside the object class. Okay, control A, control C. I am just giving you as the backup example. So since java.lang.object is acting as a superclass for every Java class in Java, so this is the practical proof. Okay, not only hash code, not only get class, not only toString method. And one more point I wanted to tell you on this context, system.out.println of obj. Sir, I am just displaying this obj. Whenever you are displaying the object of any Java class, please try to remember, it's a very, very important point. Whenever you are displaying, see, this obj is right now my Java class object. When I am displaying this object, immediately it will call toString method. Even though explicitly you are calling or not calling, when you displaying any Java class object, it is calling the toString method. Sir, toString method is there or not there? Inside your test2 class, toString method is not there. If it is not there, it is calling which class toString method? Object class toString method. What is the object class toString method? Is returning class name at the rate of hash code. That is what you need to understand. Sir, can you please show me the output? Yes. The same output we are getting or not? Yes. Okay. Explicitly you can call the toString method, or if you are displaying the object, also it is internally invoking the toString method only. Please remember this point. It will be applicable for any Java class object whenever you are displaying. Come on, please. Here I am writing the note point so that you will get the clarity. Note point. Okay, whenever we are displaying any Java class object, it is internally invokes toString method of the class. toString method of the class. Sir, if you are overriding the toString method inside your test2 class, this toString method only will be executed. If you are not overriding, it will be calling the parent class toString method, that is of course object class toString method only. What object class toString method is giving you? It is giving you class name at the rate of hash code only. So that anyhow we have seen here itself. If you want to check for any other class of predefined, Control Shift T for training, and give the class and enter. Automatically the entire logic will be coming. Whatever the graphical documentation we are seeing with respect to code, we can able to observe here itself. I hope you understand. Let me close all these things. All right. So this is the practical example. And now, yes, now we need to understand a few more points regarding the inheritance. We do have like different types of inheritances are there. Right? Single inheritance, okay, multi-level inheritance, okay, multiple inheritance, okay, hierarchical inheritance, and hybrid inheritance. So these many we do have like types of inheritances are there. If you are observing, multiple inheritance is not possible. It is not possible through the concept of classes. In Java, okay, it is not possible through the concept of classes. Yes, you may ask one question, sir, why we do have different types of inheritances? First of all, what do you mean by these? Very simple, sir. So single or simple inheritance is nothing but it contains one parent class, one child class. That's it. For example, if you have a class, and then B class, that's it. So consider A is a parent class, B is a child class. If you are observing this context, one base class, one child class, obviously it comes under what? Simple inheritance. What do you mean by multi-level inheritance? Come on, please. For example, the same concept here. Okay, A, okay, B, A, B, and then C. So what do you mean by this? Here, A is a parent class, meaning that multiple inheritance is also inheritance. It contains one parent class, one child class, and multiple intermediate base classes, intermediate parent classes. What do you mean by intermediate parent classes? Come on, please. What do you mean by intermediate parent classes? Sir, if you are observing this particular context, this B is acting as which class? Tell me. If you are observing this particular context, A is a parent class, B is a child class. Okay. If you are observing this context, the same class which is acting as a child class in the previous context, the same class is acting as a parent class now. So what do you mean by intermediate base class? What do you mean by intermediate base class or parent class? This is also a class. Which is in one context, it is acting as child class, and in another context, it is acting as a child class. So if that is the case, all such kind of classes can be considered as intermediate parent classes. So this kind of inheritance is known as what? Multi-level inheritance. This kind of inheritance is known as what? Multi-level inheritance. Yes, practically it is very simple, sir. For example, this means what? Class A is there, we have. Assume class A is there, we have. Class B, come on, tell me. Class B extends A. Okay, this is also fine. Class C extends class B. Isn't it? Yes or no? Class B extends B. class C extends B, meaning that whatever the properties which are available inside the class A, those will be inherited to class B. So that inside the class B properties and class A properties are available, and all those properties are available inside the B, and those properties will be inherited to class C. So final conclusion is one parent class, one child class, multiple intermediate parent classes. In this context, it is acting as a B class acting as a child class. In this context, B class acting as a parent class. That is what I have told you. I hope you got the clarity, right? Okay, this is comes under what? Multi-level inheritance. Programmatically, you may get this kind of scenarios. So we have to like what, implement. If you are not aware of this, it is not possible to like what implement the coding or applications. Right? When it comes to like what multiple inheritance, multiple inheritance, it's very simple, but it is not possible. Why it is not possible? I'll show you. I'll tell you. First of all, what do you mean by multiple inheritance? A, B, okay, C, something like this. And if you are observing, for example, Z, okay. So here A is what? Parent class. B is what? Parent class. C is what? Parent class. And Z is what? Child class. So meaning that multiple inheritance contains how many base classes? Multiple parent classes. And how many child classes? Single child class. So is it possible or not possible? Can you please show me the practically? Class A is there, okay. Class B is there, okay. Class C is there, okay. Like this, and so on. Multiple parent classes are there. So class Z extends A, B, C, something like this. It is not at all possible, sir. It is not at all possible. So why? Because note point is using extends keyword. Come on, please try to understand. Using extends keyword, we are always extending one class at a time. But here, based on this particular figure diagram, it is this Z is the derived class extending from multiple parent classes at a time. First of all, that is not at all possible. Practically, it is not possible. If you want, I will show you. So child, for example, one more class I am defining under top of inheritance here. For example, here class, subclass, assume. There is a subclass assume. And coming to like what child extends parent comma subclass. Immediately we are getting the errors. So see here, multiple markers, syntax error, meaning that using extends keyword at a time we are able to like what inherited one class only. More than one parent class, it is not possible. Syntactically, it is not possible. Yes, you may ask one question, why they did not design like that? Yes, for that also there is a reason. For example, inside the class A, I have M1 method is there, assume. Simply inside the B class also I may have same method, assume. Inside the C class also I may have same method, M1. We don't restrict like that, right? So ultimately class A has M1, class B has some M1, class C has also M1 method. But now I am creating the object of Z class, Z obj equals to new Z, obj dot M1 method. Which class M1 method? See, if M1 method is not available inside the Z class, obviously it will look for the parent classes. But in my all parent classes, M1 method is there. So then which M1 method will be invoked? A class M1, B class M1, C class M1. Obviously Java compiler will get the ambiguity error. That is the reason at a design level only they restricted this. Okay, we may get this kind of scenarios. That is the reason they have restricted this at a design level only. How they have restricted? Using extends keyword, only we are able to extend one class at a time. More than one class if you are trying to extend, it is not possible. Syntactical error you are getting, compile time error we are getting. Why they have restricted at design level, practically also I am explaining. I hope you understand. So that is the reason multiple inheritance is not at all possible through the concept of classes. Yes, it is possible through the concept of interfaces, especially by using Java 1.8, which is default methods, that I'll tell you later. But right now, try to understand. Multi-level inheritance is nothing but it contains multiple parent classes and a single child class, but practically it is not possible. Why it is not possible? I told you already, right? When it comes to hierarchical inheritance, it's very easy. It's simple. Okay, it's very easy. So one parent class. Okay, reverse of the multiple inheritance, ma. B, C, D, something like this. Meaning that if you are observing this diagram, so it contains one, okay, it contains single parent class and multiple child classes. Is it possible or not possible practically? Of course it is possible. Class A is there, class B, come on please, class B extends A, okay, class C, come on please again, class C extends A, okay, class D extends A, like this. As many child classes as you want, you can define, you can derive. But for all these child classes, who is acting as a parent class? A is the parent class. Of course it is possible. Of course it is possible. We are not getting any issue. One parent, multiple child. That is comes under which inheritance? Tell me. Hierarchical inheritance. So when it comes to like what hybrid inheritance, when it comes to like what a hybrid inheritance, it is very simple. It is a combination of any two possible inheritance types. Possible inheritance types. Okay, so meaning that, for example, A is there. Okay, A is there. Okay, and after that B is there. Okay, after that C. Okay, after that C, and then D. Okay, and then E, like this. If you are observing this diagram, okay, if you are observing the first context, what kind of inheritance it is? If you are observing this first context, what kind of inheritance it is? It contains one parent class, one child class. What type of inheritance it is? Come on, please. What kind of inheritance it is? I'm seeing your chart box. What kind of inheritance it is in the first context? Whatever I am selecting here.
Level inheritance.
Right. So please give your chart box answer. So A and then B, if you are observing, this is a simple inheritance or single inheritance because it contains one parent class, one child class. When you are observing the second context, one parent class, multiple, one parent class, multiple children's, meaning that it is a hierarchical inheritance. So it is a combination of simple inheritance and a hierarchical inheritance. Don't you feel this is a hybrid inheritance? It is a combination of any two possible inheritance types, not only single and then hierarchical. It might be single and then multi-level. It might be multi-level and hierarchical. It might be something like that. But make sure in that combination, come on, make sure in that combination, okay, in that combination, multiple inheritance is not allowed. Is not allowed because if you are trying to use multiple inheritance in that combination, that entire hybrid inheritance is also not possible because of multiple inheritance is not possible na? So in this way we need to understand regarding hybrid inheritance. Practically you might get this kind of scenarios, but we need to understand the different types of inheritances also. So ultimately, so inheritance is the process of acquiring the properties from one class to another class. Practically to achieve this, we are going to use extends keyword so that we are able to get the properties from the parent to child. And whenever you are applying the inheritance, it is highly recommended to create the object for the child class so that memory will be created only once. Okay, memory copy will be created only once. That I wanted to show you whether it is really gets created only once or not. Just a wait. Since the concept coming into the picture, I'll try to show you. Okay, public parent, or else 1 second. Let me save this. Let me try to delete this, which we don't want. Let me try to. Okay, since I took the backup, not a problem. Now inside the parent here, I am defining one constructor assume. I'm defining one constructor assume system.out.println this dot hash code. Okay, so this is all about parent and come to like what child. Here also I am removing this child system.out.println this dot hash code. Save it. Come to like what test1 jar java. So main method, already main method was there. So child obj equals to new child. what is happening when you are running this. See here, hash code is giving you, like, when you are creating the object for the child class. Okay, so from this control goes to this child class constructor, and it is giving you the current class object hash code. From here, control is going to like what parent class constructor also, and this will be also executed. So both the parent class object and then child class object is giving you the same hash code or different hash code. Same hash code, meaning that when you are creating the child class object, memory copies will not be created. Alag it will not be created. Only one memory copy will be created among all these parent and then child classes, but it will be distributed whenever is required. So that is the concept of what? That is the concept of only one memory copy will be created. Okay, when you are applying the concept of inheritance. So this is the practical proof. Since we are getting if you are getting the different hash codes, obviously we can believe different memory copies will be generated. But since we are getting the same memory, same hash code values, meaning that even though when you have a parent child classes, two different classes, since it is maintaining the relation, this inheritance is creating only one memory copy, and that will be distributed wherever and which class it is required. So this is also I will try to like what give you the one note point here. When we apply the inheritance concept, okay, it is highly recommended to create. It is highly recommended to create the. It is highly recommended to create the object for child class. Even though, okay, when we create the object for child class, two memory copies won't be created, won't be generated for both parent class and child class. Only one memory copy gets generated, and that will be accessed by both parent class and as well as child class. So please try to understand this example. Parent.java, child.java. So here I'm using this where this is representing the current class object. Yesterday's or day before constructors concept we have already discussed. Okay, Control C. In the child.java, Control C. Test.java also, let me copy. I think test one it is. Yes. Still, if you are not understanding this, yes, we do have a little knowledge is required. Yes, you may ask one question. We are not calling the parent class constructor, but how it is control is going to here and that will be executed, that I will tell you later. But ultimately, that is not my intention here. What my intention is, when you create the object for the child class, when we are in the inheritance concept, the same memory copy will be created for both parent and as well as what child. Individually, different memory copies will not be generated. That is only the conclusion. Okay, so this is all about what? Inheritance. So this is all about what? Inheritance. Thank you.